along y-axis, velocity along that axis. Look at the force, how it is. I think you'll get pain. Try to put your finger into the screen, you'll get a pain. If you're getting pain, okay, fine. So they'll be along negative x-axis, no? This will be, so when, so you draw a small diagram. So you have to construct situation here. So once you can get, this is, so here what you can do is like, I'll bring this rectangular coordinate axis. It will be z-axis, negative z-axis. Okay, let's get into the discussion now. Now this will be the z-axis. Very simple. If you can put effort, you have to put effort. Minus x plus x minus x. This is y. Okay, this is z-axis. Let's get into problem. So initially the particle is here. So the field here will be along y-axis. So therefore, how the particle will move? It has to move in a z minus x plane. It will come here. So the moment it enters like a here after this, so get the velocity vector. Because the force here will be acting in this direction. F1, I'll call it. The moment here now, how the B bar B bar will be like this. How the force should be, now bring that one. B bar and the velocity. Now I think now also you'll get very good pain. Anybody, how the force will be? Negative y-axis. Negative y-axis. So the force here will act along negative y-axis. How the particle should move now? Should move in the which plane? Z minus y plane. Z minus y plane. So here it's not possible. Okay, rough diagram, if I put it, will get confused. Z minus y plane. Then again it will enter into the plane. So now you see that. Three-dimensional not possible for me to show. It will enter minus z minus y plane. Okay, yeah, fine. Okay. So here I think we'll construct the planes here. This is, I think, this much of long not possible y-axis. We'll make it small. We'll get some space. Yeah. Similarly, this one. I'll get some place to scribble. Bx. Let's get into the next part. Okay, I'll do one thing. I'll call O. The where it entered, I'll call P1 first time. Next from P1 to P2. For that, what is the axis we should write here? Minus y minus z plane. Minus y minus z plane. Then it will move. Like this. So here how the field will be directed. out of the plane. I think it's justified if you look at all the things. So velocity, b bar velocity. So the force here will be acting in this direction, F2. Because of that, it's going to move in its curved path. And it will spend in this particular plane certain time. Then again, what happened? Again, it's similar to like this only. But where do it will not be at origin? It will enter somewhere here. Then what is the motion? Again, it will go there. It will be like this. So how it will be moving? It x coordinate will increase, minus x coordinate, minus y coordinate will keep on increase. No. Hope everyone is able to imagine. I can't draw the diagram more than this. I'll just show it. So here the particle will go like this. Then in minus y minus that plane, again it will be, the path of the particle will be of this kind. Determine the coordinate of point where the particle crosses the plane z equals 0 for third time. Which plane can we show both the things? Anybody? Best brains, I want really to answer this. In which plane? So this is minus yz plane. Earlier I shown that is in zx minus plane. In which plane I can show both the trajectory? Is this possible? So shall I say that after certain every half of the time interval, it will be parallel. It will be like this somewhere. This will come here. This red color one I have to draw it somewhere here, and this black color one it should be somewhere here. What do you mean by it will move in xy plane? Please understand. Please think once. How particle will move in xy plane? Because of mind field, your open eyes, Sri Vignesh, open eyes. Red color path is there in x minus xz plane. Z equal to 0 when it crosses, Z equal to 0 is telling. So when it comes and touches the xy plane for the third time, that was the question. It's not telling that it will move in xy plane. You have to improve your language, very important. Huh? Okay, now. Now first, shall we'll keep on give the coordinates. So this was the point P1. This will be P2. What are the coordinates of point P1? At least I think we'll be in a better position. Time taken to reach at point P1. We'll also write, I think, what is the time period? Time period is given by BQ by M, 2 pi BQ by M, 2 pi M by BQ. So what is the time taken? This will be off of this. Time taken to reach from O to P1. Okay, we'll write all the things, at least it'll be there. So what are the coordinates of point P1? Coordinates of point P1 will be coordinates of point P1, radius of this equal to M. I think it will have different radii for small r and capital R, right? Small r will be related to this. Capital R will be related to this one. Small r equal to mv by q by. Now what should be the coordinates of point P1? Should be equal to minus of 2r 0, 0. And then after this, time taken to move from P1 to P2 should be off of the time period of revolution. But the magnetic field will be same, no different. I think I should introduce this Tx. Okay, I had to, lot of symbols are there, no? T dash, I'll write it. Huh? We'll do one thing, R dash, R double dash, T dash, T double dash will write. T double dash will be 2 pi M by By Q. R double dash will be mv by q by. We'll take help of these symbols. This will be better for us. R double dash. Okay, this will be t double dash 2, the coordinates of point P2. Now I think we'll be in a better position. We can answer things very easily. Coordinates of point 2, x coordinate will be as it is, 2r dash it will be. Y coordinate will be 2r double dash, z coordinate will be 0. Please follow this. Then again the particle, what happened, will move from P2 to P3. How do it will move? It will be moving in again due to magnetic field By. So here P2 to P3. This will be equal to T dash by 2. What should be the coordinate of that point? Coordinate of point P3. It should have the displacement of 4r dash. Y coordinate will be as it is, 2r double dash, and this will be 0. Time taken to move from P3 to P4. P4 as it is, this will be 4r dash will come, this will become 4r double dash. Check it now. Third time is telling, okay, now verify all the things. Shall we take third time means P3 or P4? Shall we take this is what required answer, or shall we go for this? Bx. Okay, yeah. Anybody? Shall I go for this or this one? Third time. Crosses the plane z equal to 0. Third time. P3 only is asking. So this is what our required answer. So for this, we will. Okay, here we have to, there's no other way. We have to construct here. No, for what is r dash value? R dash, we have brought it, mv by q by. 2 double r dash. Very good imagination is needed. It's not like something mass or something. Here, maximum students, what they close eyes, try to imagine. You have to construct a diagrams. You have to put effort. Hard work is needed. Drawing diagrams. Laziness of mind will not permit you to do all this. Look at your teacher, how I'm struggling, drawing diagrams, everything, trying to explain. If you do that, it'll be easy, no? Without effort, we want everything. There is a major problem now. Okay, we'll bring the next helical path. We'll take the helical path condition. Now let me project a charge particle in a magnetic field.